What's up, guys? Well, today we're gonna do a complete walkthrough of the quiz 9, and I have to say this quiz is actually a lot simpler than the one we had last week. So let's just get started, shall we? So I have got my boiler codes here, written by Eric Martin. And this is also written by him, so we're gonna take advantage of this file, yeah, to create to complete the requirement of this quiz. So let's just analyze the requirement, shall we? So randomly generates a binary search tree whose number of nodes is determined by user input, which is pretty usual, with labels ranging between 0 and 99999. Display it and output the maximum difference between consecutive leaves. Okay, there's several key words here. The first one is the maximum difference and consecutive leaves. Okay, these are really important. So let's just get a conceptual understanding, shall we? So okay, so here is a quiz document. So let's just look at the first examples. How would the tree look like? Okay, actually, to be honest, this tree is a bit, I have to say it's a bit drawn in a quite unusual way, because normally we got the tree like, for example, I got a tree like this, yeah, 7, 9, which is drawing a vertical style, right? But actually, you know what? For this tree is actually drawing a horizontal style. So the tree is actually like this. Okay, so this is the root extended towards the east. Okay, towards the left. Okay, this is the children of the root, okay, and which has got another children, which is this one, okay, 794,772, okay, which is all pretty straightforward. So what is the question asking, okay? So if you look at the first example, the maximum difference between consecutive leaf is 0. Why is that? Because we only got one leaf. Okay, a leaf is a node with no children. Yeah, remember that. Leaf is a node at the very tail end with absolutely no children that can be derived from it. Okay, so here is a really important criteria. So now let's look at the second example, which is actually built upon the first one. So now this root got another branch, another children. I mean, each binary node can have up to 2 children, okay? So here is another one, okay? So actually, you know what? If you have tested in a console, you're actually gonna find out that the right node is actually this one. The left node is the upper branch. So it's kind of inverted in a way. So that's something to bear in mind. Okay. So yeah. So if for the second example, obviously we have another leaf, right? This is another node with no children. So if you compare these two, right? For now, obviously we only got 2 leaves. So the only difference between them is this 138,716. Okay, so this is all pretty straightforward. But if we have a look at this example, okay, you will find that obviously this one is gonna be a leaf, and this one is gonna be a leaf, right? And we got another leaf here. Okay, so consecutive leaves, like these two are consecutive leaves, these two are consecutive leaves. We want to find out each and every single difference between consecutive leaves. So right now we got two sections of differences that we can compare. Yeah, so obviously for this one is the largest difference is between 933,488 and 441,001. Okay, so we need to compare the two differences in a way. And this one is even more complicated. It will also build upon the last example. So right now we got this node, which is a leaf, leaf, leaf. Okay, so now we got let's just analyze. So this is a leaf, right? This is a leaf, leaf. So it looks really carefully because so if you have a look, the maximum difference is actually between this one and this one. Okay. So yeah, and it's pretty much the same principle for the one below. So let's just implement algorithm, shall we? So we need to find a method that, because we want to compare consecutive leaves, so we need to find those leaf nodes consecutively. Okay, find them one by one. So the first concept that really come into my mind is depth first search. So what is a depth first search? It's like, okay, for example, we got A, B, C, okay, D, E, this is another branch, A, B, C, D, E, F, G, okay. So depth first search is like, we're gonna find each and every one of these leaves consecutively from left to right, okay. So we're gonna find A, B, D, right, first, followed by E. After exploring the left section, we're gonna move on to C, F, then followed by G. So depth first search will find those leaves in a consecutive way, right? So that is the algorithm we want to implement, okay? So let's just get started. So there's plenty of hints here. So possibly define some function. Okay, so I'm gonna do just that. So we're gonna define a function that says, let's just say find leaf nodes, shall we? Okay. And the argument I'm not too sure about at this stage. There's several conditions we need to think about, right? Obviously, I mean, for the boundary case, it's like, what if the tree is empty, right? If the tree is empty, what's gonna do? Like, there's absolutely no nodes inside. So that's something we need to take care of. Okay, so let's just implement the first one. So if a tree, yeah. So obviously we need the argument here. Okay, if tree dot value, okay, we can get y is a value because we have defined in these files. Okay, so we extract the integer value. Okay, so if this value is none, yeah, what you're gonna do? Obviously return nothing. Okay. And there's another thing we need to consider is how are we going to decide whether a node is a leaf, right? So basically, if for example we are looking at this node D, there's no way to find a left node or a right node. So in a case we have a double conditions. Yeah, so if both of these nodes are none, right? If both left and right nodes are none, then we can pretty much say that this node has no children, therefore it can be classified as a leaf. Okay, so we have a double conditions, like if both left and right nodes are none. Okay, so we can say if tree dot left node dot value equal none. Okay, another condition is tree dot right node. The reason we use left and right node is because it's also defined here. Okay, in this binary tree ADT Python file. So the tree, right, if this is also equal to none, yeah, I mean, I prefer this way of writing conditions instead of using AND, right? I think it's easier to understand. Okay, so what you're gonna do with this? Well, it's you're gonna create a list. Okay, so what we want to really build is a list that contains all the values of those leaf nodes. Okay, so it doesn't matter where you define it, but I'm gonna define an empty list here. So I'm gonna call it leaf list. Okay, an empty list. So over here, I'm gonna say if this node has no children, I'm gonna say leaf list. Yeah, leaf list append. Okay, this node. Okay, so I mean the tree is a bit confusing here, because usually if you just after creating a tree object, if you put in the console like tree.value is actually going to give you the root value. So this tree originally starts with the value for the root, but as you go all the way down, it's actually changed to the last node. Yeah, so you will see how it works out. So we're gonna append. So at this stage, we're gonna just append this this node because it has no children. Okay. Then, so what are we going to do with the node that actually have children? So we need to define like if this node here, if this current node has a left children, okay? So we're gonna say if tree dot left node is not equal to none, then we're gonna recursion. We're gonna use recursion. Okay, we're gonna do this, run this function recursively until we find the children. Okay, so we're gonna find leaf nodes, right? And we're gonna put the argument. Actually, you know what? I want to put another argument here. I'm gonna put leaves list over here. So this should make it easier. So here we got obviously let's just think about this. For example, if we are at node B, yeah, so we're gonna test, say, okay, if the left node of B, which is D, is not equal to none, okay, then we're gonna run, yeah, we're gonna run the function again to test whether D has got any children. Yeah. So we're gonna say tree dot left node. Okay. Then obviously we also got a leaf list, which is growing all the time. And the last conditions probably we're gonna, to test if this current node has a right children. Actually, I think it's more appropriate to say a left child and right child. Okay, whatever. So I'm just gonna copy this this code here, and I'm gonna change the left to right. Okay, change the left to right. And actually really straightforward. Now we have got a function that's gonna return a full list of values of leaf node. Now it's the easy part. Really, really simple. Really, really straightforward. So here we're gonna find the differences between successive left leaf nodes, yeah, inside the leaf list. Okay, so let's start by define another list array. So we're gonna call that's gonna store all the differences. Okay, so for example, if we have 3 elements, then 3 elements inside the leaves list, then the length of this leaf differences, okay, it's gonna be 3 minus 1, which is equal to 2, right? So that's something to bear in mind. We're gonna, so over here we're gonna just copy this function. I'm gonna run the function right here. Okay. So now it's time to remember that we actually got several cases to remember that if you look at the quiz document, the very first example, right, is only got a single leaf. So there's nothing, there's no second leaf node that can be compared with this leaf. So if there's only a single branch, so the difference is obviously gonna be 0. I mean, this is the boundary case that we need to take care of. Okay, so we're gonna just say if the leaves list, right, is empty or is of a length of only 1. Okay, so that's that. And so it's really easy to define. So if the length of leaves list, right, is less or equal to 1, okay, then in that case the maximum difference is always going to be 0. Then there's an else element we need to define it, and that is going to be, we need a for loop. Yeah, we're going to need a for loop. For example, if we got all the leaf list, right, we just write some number, random number, whatever. For example, if this element is gonna be our leaf list, then the leaf different list is gonna be, you tell me, what's this? 1. What's this? 1. What's this? 3. And what's this? 1. So we need a list like this. Then we're gonna apply a max function, right? The inbuilt max function. Then we're gonna find the largest difference. So you tell me, what do we need? We need a for loop. Okay. So for each leaf in range, so I'm gonna say the length of the leaf list. But bear in mind, this list is actually gonna be 1 element shorter. So we're gonna say, because obviously the last element cannot be compared with because there's no nodes after this one, this 4. So we're gonna say that we have to subtract this 1 because this different list is 1 element shorter. Okay. So the difference, okay, we're gonna define a difference of absolute values, okay. That's really, really important. Of leave list, each leaf. So we grab for example, we grab the first element, right? Then minus this second element. That is gonna be, okay, just copy and gonna plus 1. Gonna grab the next element. So we're gonna get our difference. Now we're gonna append, okay? We're gonna append this leave difference, this different to this our list, the different list, okay? Then we can, then at the very end, yeah, at the very end, after obtain or constructing our different list, then we can say that outside the loop, remember, the max difference, yeah, is gonna be the maximum, yeah, of the different list. Okay, really straightforward. I'm gonna delete this thing. Okay, so now we're gonna finish off this function. It's gonna return max diff. Okay, it's just gonna return max diff. So guys, we just finished it, you know, we just did it. It's really simple, isn't it? I mean, this could be one of the easiest quiz at least compared to the last one, right? So we're gonna just run. Yeah, we're gonna select everything, Control A to select all, and Control Enter to run. And we're gonna test one by one. Okay, the first one is gonna be 0, 3. So the first number is gonna be the random seed. Okay, so we always produce the same output. And then the second number is the number of nodes. So over here we have 3 nodes, so we got 3 here. So yeah, so the maximum difference between consecutive leaf is 0, which is exactly right. So then let's test the next one. Actually, why not? Let's test the last one, shall I say? Okay, let's test the last one, the most difficult one first. Okay, so 3, 10. The maximum difference is, wait, what the hell is happening? I think something went wrong here. I don't like this. So let's just rerun everything. Yeah, let's restart the kernel. Something is wrong here. Let's see whether we can. Wait, just select everything. Let's just do 3, 10. Oh no. The max difference is still not right. So what is happening? So guys, I'm gonna just pause there, and because I'm running into problems, it's quite. So we're gonna maybe see you again later after I discover all the bugs. Okay, gonna see you later then. Bye.